Hello, students. Today we will study some more things in detail about electricity and magnetism, or more specifically, electromagnetism and electromagnets. So, the topic for today's session is spoon bell. Okay, now you will get the idea why we have labeled this topic as spoon bell uh, in the due course. Let us see. The first question: what is magnetism? And second question: what are magnets? Let us study them. What is magnetism? Okay, magnetism is a force of energy. Okay, yeah, but what is magnetism actually? Magnetism is that force which is exerted by magnets. Okay, magnetism is that force which is exerted by magnets. Now, what are magnets? Magnets is a thing made out of iron or steel, and it can attract magnetic material made out of iron, steel, cobalt, or nickel. Okay, so these are magnets. Magnets is things which are made out of iron or steel and can attract iron, steel, cobalt, or nickel. There are also category of magnets called as temporary magnets and permanent magnets. So magnets are divided in two types. First type is permanent magnets. Second is temporary magnet. So we are going to study temporary magnets today. Permanent magnets are the magnets which are permanent. The magnetic properties are constant. But in temporary magnets, they can be magnetized depending upon the current which pass okay through the wires. We will study them. What are temporary magnets and how can make them? A temporary magnet is a magnet that can be demagnetized also and which can also be magnetized. Let us study them. The temporary magnets are called as electromagnets. What is an electromagnet? Now the interaction between electricity and magnetism, it's called an electromagnet actually, or electromagnetism. More specific word over here is electromagnetism. The interaction between electricity and magnetism, it's called electromagnetism. Electromagnets are devices that create a magnetic field through the application of electricity. What are electromagnets? Electromagnets are devices that create a magnetic field through the application of electricity. What is this magnetic field now? The magnetic field is that field which is exerted by a magnet. Okay, let's say that this is a bar magnet. Okay, bar magnet is a type of permanent magnet. Here is the north pole of magnet and here is the south pole of magnet. The field exerted by this bar magnet can be shown like this. Okay, like this over here, like this, like this. Okay, you might have seen this diagram. Okay, so this field over here is given by this particular type of bar magnet. Okay, and these are the magnetic field lines. Okay, the lines which I have drawn over here, these are the magnetic field lines. And these types of magnets, electromagnets I'm talking about, are common examples in doorbells and motors. Okay, electromagnets are mostly used in doorbells or motors, and there are many applications of electromagnets. Let us study them. A simple electromagnet can be made using an iron nail. Okay, you must coil wire around it and give and apply battery. Okay, and apply the force through battery. Here's an image depicting a very good electromagnet. Here is the copper wire wounded over here, and once wounded once over there, and then again wounded in this direction also. And here are the two terminals. One is positive terminal of battery, one is negative terminal of battery. Okay, so this is a simple, very simple electromagnet over here given. Okay, here is an iron nail, the turnings, the coiled wire around it, and the magnet. So this type of magnet, which is dependent on the battery for its magnetic properties, is called an electromagnet. Understood? This is an electromagnet. There is an iron nail, wire, and a battery. Now, so this is a STEM card: science, technology, engineering, mathematics, and we will make a fun, experiment. Right? Let us see what that experiment is. For that experiment, you require 1.5 volt cell and copper wire, metal spoon and tape, You require metal spoon and tape. You'll require long nail with a broad top. Okay, the top is broad. You can see here. You will require a wooden base. You'll require a small piece of wood and a screw and hammer. Okay, these screw and hammer. Now let's go to the procedure. Take the copper wire and wrap it around the long nail to form a set of circular rings. Now, what's the first procedure to do? To form an electromagnet, right? This is an electromagnet. Take the copper wire and wrap it around the long nail. What does it makes? It makes an electromagnet. Second, using the hammer, carefully place the long nail in the wooden base. So on the wooden base, you will carefully place the long nail. Then place the spoon slyly atop the nail's head. Okay, you know, spoon is made of steel, isn't it? Spoon is made of stainless steel. You should know this. Place the spoon slyly atop the nail's head with a thread's gap. So there must be a little bit gap in between your long nail, this long nail, and the wooden base. Let's say this is my wooden base like this. I'll draw and show you. Here is my nail like this. It's with broad end. Just a minute. Okay, so here is my nail. I've inserted it inside here. Okay, and here in this end, there is the spoon kept. Okay, here is the spoon kept. Okay, there must be very a threads length. I've written here. They have written here with a threads gap. So the gap between the spoon and the nail must be very small. Okay. Now support this metal spoon with adequately high piece of wood and tape that end on the spoon. This long nail must have windings, electrical windings, the windings of that copper wire. Okay, the electromagnet must be there. Now with this setup, what you will do is connect the two ends of copper wire to the two ends of the cell. Okay, so these are the two ends coming from this copper wire. Then connect it to a cell. Okay, connect it to a cell. This is my cell, CELL, and make a note of your observations. Now, what do you think? What will happen? Yes, this will form an electromagnet, and this electromagnet pull the uh, will pull the spoon towards itself. Okay, you know why? Because spoon is made of stainless steel, and stainless steel is attracted by the magnet or the magnetic force. This particular electromagnet will exert its force on this spoon and will attract it. Okay, and this is how the principle behind electric doorbells, and that is why the name spoon bell. Okay, understood now. Think time for all of you, but before that there are some notes to discover. The flow of electric current through copper wire generates a magnetic field. Okay, this copper wire over here, the flow of current through it, like in this spiral way, generates the magnetic field. This magnetic field attracts the spoon towards it and strikes the top of the head nail to produce a sound that is similar to a sound of a bell. Isn't it? It's like a bell. So this is the main aim and procedure of the experiment. Now, think time for all of you. Discuss some real life usage of electromagnets around you. Oh, there are many uses. Okay, first is the doorbell. Second is electric motor. Everywhere electric motors are used, electromagnets are used, and electromagnets are also used when to separate the garbage. Okay, to separate iron materials from garbage. There are many uses. Okay, you can find many uses on the internet as well. Now, one question: what if instead of one long nail there were three copper wound long nails? Hmm? What would have happened if there were, instead of one long nail, there were three copper wounded long nails? There were three nails. Okay, what would have happened is the the magnetic force would be much more greater in that case. Okay, and when the magnetic force is greater, the spoon would have attracted with more force. Okay, it would have attracted with the more force. Understood? Okay, this is all for this lecture. Thank you.